Good day, everyone. My name is Lynch Manangkil, and I choose the field of civil engineering, and I will teach you how to derive an integral. But first, in integral calculus, we have two types of integral. We have the definite integral and the indefinite integral. The definite integral is the integral that is defined by the limit values of an independent variable. Basically, this is an integral that have an upper limit and a lower limit, while the indefinite integral is the integral with no limits or its independent variable. For our first example, let's evaluate the integral of t cubed plus 1. In this example, we can use the sum rule, meaning we can integrate separately t cubed and 1 to integrate t cubed dt. We can use the variable rule, so t cubed plus 1 over 3 plus 1 plus we can use the constant rule. So here it's t. So simplifying, we now have t raised to 4 over 4 plus t plus the constant c. And now for our second example, let's evaluate the integral of the quantity 3 minus 1 cube. And this example will let u be equal, we let u to be equal 3 minus 1 so that it will be easier to integrate. So getting the derivative of v, we now have 3 dt. We have dt is equal to 1/3 of du. We can substitute these variables in the given equation. So we integrate u cubed, substitute dt. We now have 1/3. The u, since 1/3 is just a constant, we can apply the constant rule. So we let 1/3 outside the integral sign. So it will be 1/3 the integral of u cubed du. Now performing the variable rule, we now have u raised to 4 over 4. Now we can substitute the u here, which is 3t minus 1. So it will be equal to 1 over 12. The quantity 3t minus 1 raised to 4 plus the constant c. And for our methods of use innovative trends in civil engineering is to perform performance that build to last. Highways, bridges, tunnels, and other public construction, our road safety, sustainability, and energy efficiency are non-negotiable for our civil engineers. To meet these challenges of increasingly complex world, the industry needs better solution, and that is to invest in good materials like steel and standard reinforcement materials. That's all. Thank you.
My report is from mechanical engineering, and my problem is an oil storage tank ruptures at time t is equal to 0, and oil leaks from the tank at a rate r of t is equal to 100 e raised to negative 0.01 t liters per minute. How much oil leaks out during the first hour? For our solution, we have to first get our mathematical equation, which is v is equal to the integral of 100e raised to negative 0.01 t dt, which we will integrate from 0 to 60. We have to use the substitute method. U is equal to negative 0.01 t, and our du is equal to negative 0.01 dt, which we can get dt is equal to negative 100 du. For the corresponding u limits, we can change 60 to negative 0.6 and 0 to 0, so it will be easier for us to solve. Then we can arrive to the integral of 100 times negative 100 eu du, which we will integrate from 0 to negative 0.6, and then we will arrive at negative 10,000 e raised to u, integrated from 0 to 0.6, negative 0.6, and we will arrive at negative 10,000 multiplied by the quantity e raised to negative 0.6 minus 1, and our final answer, the amount of oil that leaks after 1 hour is approximately 4,512 liters.
Hello, I am Darlene J. Makotak, and I am going to talk about a work application problem that uses methods from the lessons I learned from my subject, Integral Calculus, for my chosen field, Chemical Engineering. The question that I have chosen was this. A small water reservoir is to be constructed in an industrial area. If the water reservoir is 9 feet deep, how much force acts on the end of the parabolic end of the reservoir? Take note that the weight density of water is 62.4 pounds per feet cubed. Now let's say we have a small water reservoir that at the end of that water reservoir, if you take a slice of that water reservoir, you can see a parabolic-like shape. And you know that parabolic equations are y is equals to x squared. Now since we have this equation, even if we have this value, x equals to negative 3, which is in this line, or x equals to positive 3, since it's not a solid line, it's in a curve, we can safely say that our x is equal to, at this side, negative square root of y, and at this side, positive square root of y. Therefore, our length can be both of these sides multiplied together, which is x is equals to 2 square root of y. The depth of this parabolic graph is also 9 feet deep, which is y is equals to 9 feet. The thing that is being asked in this problem is this: a force that acts on the parabolic side of the reservoir at a depth of 9 feet. Now we can go on the formula, which is dF is equals to pressure times dy, and pressure, it can also equal to weight density times depth, and the length is from dy. To solve this specific problem, since we can't solve the entirety of this parabolic equation, what we have to do is take a slice out of that parabolic graph and derive an equation from it, which is what we saw earlier here in this formula, which is this. The dF is equals to weight density times depth times length times dy. The dy is this, which means the change in y. Taking note of all that information, we can safely say that the solution would be dF is equals to 62.4, which is a specific weight, 9 minus y, which is the depth, and the length, which is 2 square root of y, and dy, which is this slice. So if we solve everything from here, it would only give us the area of this specific slice. So therefore, what we need to do is take all of these sides and add them from the lowest value to the highest value, which is this integral of df from 0 to 9, which is also equal to force is equals to 62.4 times 9 minus y times 2 square root of y dy from 0 to 9. Since 62.4 and 2 is a constant, we can just take it out of the equation and we can solve the remaining values inside, which would equal to 9y raised to 1/2 minus y squared dy, which you can use a power rule on if you separate these two terms, which then if you integrate that, the 9y raised to 1/2 would equal to 9y 3 over 2 over 3 over 2. Then y is equals to 3 halves would equal to y is equals to 5 halves over 5 over 2. Then from this, you can evaluate it from 0 to 9. Since if you substitute 0 in this equation, the entire equation will just equal to 0. Therefore, this is 0. But if you substitute 9, it would equal to this equation, which is 124 plus 8 times 6 times 27 minus 0.4 times 243, and from this would become positive, the end would become positive, and then it would equal this final answer.
And I choose the field of materials engineering. Let's derive an integral. Example: if 6 joules of work is needed to stretch a spring from 10 centimeters to 12 centimeters, and another 10 joules is needed to stretch it from 12 centimeters to 14 centimeters, what is the natural length of the spring? Let's compute it. Solution: let the natural length be L, then we can write equation 1 is 6 and equation 2 is 10. As you can see, we divide the equation 2 by equation 1. 10 over 6 equals 14 minus L squared minus 12L squared over 12 minus L squared minus 10 minus L squared. Recall that a squared minus b squared is equals to a minus b and a plus b. So you can see the answer. Cross multiply. 55 minus 51 is equals to 39 minus 31. Add 5L on both sides. 55 equals 39 plus 21. Subtract 39 from both sides. 16 equals 21. Divide both sides by 2 and equals to 8 equals 1. Answer. Natural length of the spring is 8 centimeters. Methods of use in innovate trends in materials engineering. Materials are ubiquitous, so pervasive, we often take them for granted, yet they play a central role in much of our daily lives, in practically all manufacturing industries, and in much research and development in the physical and engineering sciences. Materials have a generality comparable to that of energy and information, and the three together comprise nearly all technology. For the COSMAT purposes, we define materials as the substance having properties which make them useful in machines, structures, devices, and products. Thank you for watching.